Hi Math 2E. Let's look at page 10 of our packet and a method of dividing polynomials called synthetic division. So first of all, in order to use synthetic division, some things have to be present. For our divisor, that's what we're dividing by, has to be a binomial. So for example, some things that would be a yes if we were dividing by the factor x plus 3, or x plus 5, or x minus 6, or even a fraction, x minus 1/2. But some things are not a binomial that won't work, such as a monomial, one term. Let's see what else. Our divisor also has to be linear, which means my x term has to be the first power. So something like 2x squared plus x wouldn't work for synthetic division as a divisor because I have an x squared there. And my coefficient, that is the number in front of my variable, has to be 1. So for example, I couldn't use 3x plus 1. I couldn't use 1/2 x squared plus 2x plus 3. So if you look down my yes column, these are all linear, x to the first. They all have, they're all a binomial, two terms, and they all have a coefficient that is 1 in front of my x. So how do we do synthetic division? Here's a worked out long division problem from our last lesson. Let's see how this would look as a synthetic division problem. So for synthetic division, you take your factor, which in this case was x minus 2, and you solve it for your root. So your root would be a positive 2. This is my factor, which gives me x equals positive 2 for my root. 2 is what I'm going to use in my synthetic division for my problem. We put a little 2 there and a backwards L. And then we write the coefficients of our polynomial. So if you look over here, this is my green polynomial. The coefficient on my green x cubed is 1. So I'm going to write a 1 there. The coefficient on my green 3x squared is a 3. The coefficient on my negative 4x is negative 4. And the coefficient on my my integer term, negative 12, I just write my negative 12. So I went over here, let me grab my highlighter, and I basically just took the coefficient on my x cubed term, the coefficient on my x squared, the coefficient on my x term, and my integer term, and I just wrote those in their own columns. If I didn't have one of those terms, like I didn't have an x term, I would plug in a 0. You'll see that on the next example when I do it with you. So back to this. So to start off synthetic division, you just bring down your first number. It's a pattern, so I'm going to bring down a 1. And now you multiply. 1 times my 2 that's inside my backwards L is 2. So now I add, and I get 5. Again, I'm going to multiply by my 2, and I get 10. I'm going to add, and I'm going to get 6. Again, I'm going to multiply by that 2, and I'm going to get 12, and I'm going to add. Lots of times, I'm going to get a 0 here. This is my remainder, and it tells me lots of things. But first of all, how do I get my answer from the 1, 5, and the 6? So always your answer, which is my quotient, sorry I spelled that wrong, quotient, is 1 degree less because I divided by something, that was linear. So I'm going to go down a degree. So if you look over here, originally my polynomial was degree 3. So my answer is going to be degree 2. And that 1, 5, and 6 you see, those are my coefficients. So since it's degree 2, I'm going to have 1x squared plus 5x to the first plus 6, and my remainder is 0. So this is my answer. This is my quotient, if you will. And I know several things. So first of all, I know that x minus 2 is a factor. This is because my remainder was 0. If in this polynomial